welcome back. Today we watch a builder transform standing pine into a winter-grade shelter, using nothing but raw materials and hand tools. Heavy machinery handles the initial clearing, but the true craft relies entirely on raw physics. A solid foundation dictates everything that follows. Digging below the frost line prevents the freezing earth from heaving the structure upward. The yellow string grid ensures each concrete pier remains perfectly level across the uneven forest floor. Dry concrete requires a precise ratio of water to achieve maximum compressive strength. Inserting ribbed steel rebar into the wet mix ties the cylinder together, preventing shear failure under the immense weight of the future log walls. Square wooden formwork is built around the cylindrical core. This wider footprint distributes the load over a larger surface area of soil. Shoveling the final wet mix requires working quickly before the concrete begins to set. A level block ensures the first log course will lay flush. Stripping the bark is essential for longevity. Bark traps moisture and invites insects, which accelerate rot. Removing it exposes the dense heartwood to the open air, allowing it to season and harden over time. Halving the massive trunk creates a flat, stable sill log that will anchor the base of the entire cabin structure. A mechanical hand winch multiplies human force, allowing one man to maneuver dead weight with ease. Scribing is the language of log building. The tool traces the exact contours of the lower log onto the upper one. By transferring this geometry, the builder knows exactly where to cut. The initial bulk is removed with a chainsaw, scoring parallel lines to depth. An axe then chips out the waste wood. This technique creates a saddle notch, interlocking the corners tightly against the wind. Refining the notch with an axe requires reading the grain. Taking off too much material compromises the joint. A tight friction fit is the ultimate goal. Instead of metal nails, which rust and loosen, wooden pegs pin the courses together. As the green logs shrink and settle, the joint only tightens. scribing becomes a rhythmic cycle. Every single log presents a unique taper and curvature that must be matched to the course below it. Sustained axe work at this height demands a shifting stance, relying on momentum rather than pure shoulder strength to carve out the lateral groove. Leverage becomes a daily necessity as the walls rise. Using a metal pry bar and a tension strap, the heavy timber is coaxed into its final resting position. Friction holds the corner joint secure. Pushing the final log into the course locks the entire rectangular frame. Marking the cut lines in place eliminates measurement errors. The axe work up here leaves zero margin for a missed swing, refining the notch until the interlocking wood sits perfectly flush. Hoisting green pine up a ladder is a test of raw endurance. The steep angle makes the wood feel twice as heavy. The higher the wall goes, the more difficult the joinery becomes. Carving a clean notch from a ladder requires balancing the tool's impact with a stable footing. A rigged cable system does the heavy lifting for the uppermost courses. The winch prevents dangerous slips while pulling the timber smoothly onto the top wall plate. A tight interlocking joint is the hallmark of structural integrity. It requires no adhesives, relying entirely on gravity and precise geometry to stay intact. Opening up the solid wall changes the dynamic of the structure. Plunge cutting with the chainsaw severs the span, and knocking out the waist section finally invites light into the dark interior. Untreated pine degrades rapidly under UV light and rain. Brushing on a penetrating preservative seals the cellular structure of the wood, warding off mold and extending the cabin's life. Structure demands exact tolerances. Scribing the upper timber ensures the rafters will seat firmly against the log wall, transferring the snow load evenly downwards. A modern circular saw makes quick work of dimensional lumber, leaving a razor-straight edge. Expanding foam sealant fills the microscopic voids between the beam and the uneven logs. Tongue and groove boards interlock to form a rigid, continuous surface. Hammering them tight creates the structural decking that will support the heavy winter snowpack. Maneuvering a raw log into place for the roof support requires careful balance. A single misstep on the ladder could send the timber falling back to earth. Metal staples temporarily hold the beam against lateral movement. A chainsaw notch creates a permanent saddle for the intersecting roof holes to rest inside. The central pillar acts as the spine of the entire roof system. Hammering wooden braces and attaching steel L-brackets locks the base against shifting. Lifting the heavy ridge beam onto this central column is the tipping point of the build. Once secured, the skeleton of the roof is finally self-supporting. Rafter angles dictate the pitch of the roof. Precision marking here ensures water and snow will shed efficiently off the sides. Cutting a precise joint allows the rafter to sit flat on the wall front. A clean cut ensures downward force doesn't split the wood. Nailing down the final decking boards locks the rafters into a rigid, triangular truss. A waterproof silver tarp acts as a temporary barrier against the elements. It protects the exposed interior from sudden rainstorms, while the final metal roofing materials are prepped for installation. Moving inside, the floor requires its own independent foundation. Trenching into the compacted dirt and placing wooden blocks creates a level bearing point for the upcoming floor joists. Feeding dimensional lumber through the window bypasses the unfinished doorway, saving time in the bitter cold. Heat rises, making the upper wall gaps a massive vulnerability. Stuffing insulation strips under the roofline traps the warm air inside, reducing thermal bridging. Raw logs shrink unpredictably. Planing and grinding the window opening creates a perfectly plumb surface, guaranteeing the rigid glass pane won't crack as the cabin settles. A circular saw slices the sash stock to length. Nailing together a custom sash requires perfectly square corners. If the frame is even slightly out of alignment, the rigid glass won't fit, and winter drafts will easily penetrate the cabin. Cross-bracing ensures the structure remains true. Scoring the glass creates a microscopic fracture line. A clean snap follows the path of least resistance. The door jamb acts as a buffer between the settling log wall and the swinging door. Hammering a shim levels the frame perfectly. Solid wood doors are poor insulators. Sandwiching a rigid foam core inside the wooden frame increases thermal resistance dramatically. Trimming the foam to fit tightly prevents cold spots. The expanding spray foam seals the perimeter, locking out drafts and gluing the core in place. This creates a lightweight, highly insulated barrier against the freezing temperatures outside. Nailing the face planks over the insulation core finalizes the structural sandwich. The overlapping boards shed water and provide a rustic exterior defense. Heavy doors exert massive torque on their hardware. Driving deep screws through the metal strap hinges anchors them directly into the solid wood framing, ensuring the door won't sag over years of daily use. Lifting the bulky door into place requires aligning the hinges perfectly against gravity. Once secured to the jamb, the interior is finally sealed off from the relentless cold. Driving the final screws into the floorboards completes the interior shell. The light wood brightens the dimly lit space. A heavy plastic sled glides easily over the accumulated snowpack. Flat stones provide a fireproof thermal mass. They absorb excess heat and radiate it back into the room. A black steel stove is the beating heart of any off-grid shelter. Mixing a proper mortar bed locks the uneven stones into a flat, stable surface. The wooden formwork contains the wet mix while it cures. Pressing the stones firmly into the mortar eliminates air pockets, creating a solid, non-combustible foundation for the heavy metal stove. A clear protective finish seals the raw pine floorboards against dirt and spilled water. Fiberglass packed tightly around the chimney box prevents the hot pipe from igniting the wooden roof decking. Stainless steel exhaust pipes resist the highly corrosive acids found in wood smoke, ensuring safe ventilation for decades. Brushing the finish deeply into the wood grain raises its natural color and hardens the soft pine surface. The roof penetration is the most likely place for a leak. A flexible rubber flashing collar absorbs thermal expansion, while a heavy bead of sealant waterproofs the joint, locking out melting snow. Splitting dry hardwood exposes maximum surface area for the flame. Once lit, the metal firebox drafts outside air, converting solid fuel into life-saving radiant heat. In the end, structure, landscape, and daily routine operate as one system, a place that produces